going to talk about the third method here, and again, we're all eyes up. The third method, and again, I only use this method when required, when they say using elimination. Well, just give them my hint away. It's okay. But it is a valuable method, and the skills you learn from this method are important to get. Now, unfortunately, I've given my next question away. I was going to ask you what's the method called? Elimination. Now, elimination is best used when we've got two equations that are in the form, and I'll just swing this thing around, in the form too far. Y equals, yeah, this will be it's the wrong one. When I've got AY plus BX equals some number C, dy plus CX equals some number, no, I don't want D, let's go F. E and F. That doesn't make a lot of sense, so I'm going to give you some numbers because you don't like dealing with, but that's the sort of form we're looking for. When we've got Y's and X's next to each other, both equations look pretty gross. So if you looked at your homework sheet, that would have been one of the answers. Okay? Now,
wait, is it dy or AY?
AY for the first one and dy. Don't worry, I'm just going to give you an example now. Okay? So if I gave you the sum 2y plus 3x, do you mind getting that? Thanks somewhat. Yep, thank you. Equals 10. And 4y plus 5x equals... you right? Okay. 18. Let's say I had those as my equations. So I've got equation 1 and equation 2.
So we wrote this down.
Yeah, write this down. In elimination, what I'm trying to do is to get one of these coefficients to line up with the other one. So I need either my y coefficient. What's a coefficient again? What's a coefficient? A number out the front of an unknown, correct? So I've got 4 coefficients here. I've got 2y, 3x, 4y and 5x. So I need to do something to one of these equations to either get both of my y coefficients to be the same or both of my x coefficients to be the same. Yes, Riley?
Double 1.
Very good. You're 2 steps in front. So what Riley has said is 2 times 1. So what would be 2 times 1? We would have 4y. I don't want the red pen, I want the blue pen. No, I have to multiply it. You'll see why in a sec. 4y plus 6x equals 20. Is that true? If I've doubled everything, am I all good? Very good. So I've got 2 times 1. And what I'm going to do now is subtract 2. 2 times 1 minus 2. So below here, I'm going to write minus 4y plus 5x equals 18. Is that okay? Am I allowed to do that? What do we know about simultaneous equations? What do we know about the x and the y value for both equations? Are they different or are they the same? They're the same, aren't they? That's what happens when 2 points meet, when 2 lines meet. X and y for both functions are the same. What's 4y minus 4y? 0. What's 6x minus 5x? X. 20 minus 18. So what do I know? X equals 2. What am I going to do with this? Call that 3. What am I going to do with that?
So
sub 3 into, does it matter? No, I'm just going to say sub 3 into 1. 2y plus 3 times 2 equals 10. What's 3 times 2? I'll do it over here now, I'm running out of room. 2y, what am I writing? Plus, Abigail? Now what am I doing? What do I want to do? What's the unknown? Because I asked you to. What's the unknown? Y. So I want to get y by itself. Minus 6, hey? Y equals, 2y equals, sorry. Divide both sides by 2. Y equals. Still works, correct? Now substitution would have also worked for this equation. The only difference is